All right, Advanced Math 8, here we go. We've got lesson 7.1.7, more congruence flowcharts. Because what's better than congruence flowcharts? More congruence flowcharts. That's the correct answer. Okay, so here we go. We've got a kind of intro lesson here on this first problem. We're going to use geometric relationships to write equations and solve for x. All right, so for part A, I see that this angle is 40 degrees and this angle is 40 degrees. Since those two are both 40, then this must be a very special kind of triangle. If these two angles are congruent, then these two sides are congruent because this is an isosceles triangle. So that's an isosceles triangle. If you've got two congruent angles, that means you're going to have two congruent sides. So what equation can I write to solve for x? Well, if they're congruent, that means the measurements are equal. So I'm going to write the equation 3x plus 13 is equal to 5x plus 2. Subtract 3x from both sides, and I get 13 equals 2x plus 2. Subtract 2 from both sides, and I end up with 11 equals 2x. Divide by 2, and I get x is equal to 11 over 2, which would be what, 5.5? 5.5 it is then. All right, so there we go. We've plugged it in, we've solved for x. We could still plug it back in and then find out exactly how long those are, but it didn't ask us to, so we're not going to. All right, so for the next one, these two arrows mean that this line here is parallel to that line. So if this line is parallel to this line, what we have is a situation where we have a transversal, and then we can use our angle pair relationships to find out what these angles are going to be. Now, I know that this angle here and this angle here are alternate exterior angles because they're on different sides of the transversal and they're both on the exterior of these two parallel lines. So when you have alternate exterior angles, they are going to be congruent to each other. So since this angle out here is 7x minus 3, we can say that this angle here is 7x minus 3 degrees. So I've got two angles right next to each other that make a straight line. Well, if they make a straight lines always add up to 180 degrees. So this angle plus this angle, since together they make a straight line, these two should equal 180. So the equation that I can write to solve for this one would be 7x minus 3 plus 4x plus 12 equals 180 degrees. Combine my like terms, I get 11x. Then 12 minus 3 is 9 equals 180. Subtract 9 from both sides, and I get 11x is equal to 171. Divide by 11 on both sides, and I get x equals 171 divided by 11. Doesn't go in there evenly, so I'm just going to leave it like that. 171 elevenths. All right, next one. Again, we've got these parallel lines. We've got a couple different transversals. We've got this transversal right here, and we can also use this one right here as a transversal. So what we're going to do on this one is we're going to use this to find out what the angles of this triangle are. There's a lot of different ways you can do this problem. This is just the way I'm going to do it. So here I go. I've got parallel lines, and this is a transversal, This angle and this angle are corresponding angles, and corresponding angles are congruent. Corresponding angles are when you're on the same side of the transversal, and then one's interior and one's exterior. So this is going to be 110. And I didn't have a lot of room for that, but I'm going to go with it. All right, so now I've got this is x, this is 110. Let's move on. Now these two angles are what we call linear pairs, because together these two angles make a straight line. And just like from that last one, if they make a straight line, they're going to add up to 180 degrees. So if this is 140, this one right here has to be 40, because 40 plus 140 is 180. All right, now I'm almost there. I can use the triangle angle sum theorem, where these three angles have to add up to, you guessed it, 180 degrees. So I know that x plus 110 plus 40 should equal to 180. So this is x plus 150 equals 180. So I'll subtract 150 from both sides, and I get x is equal to 30 degrees. All right, more congruence flowcharts. So let's do some flowcharts. This one looks like it's filled out mostly for us. So it has a new piece of terminology here. We kind of know what it means because, I mean, my goodness, midpoint, what else could it be? So a midpoint is the point that splits a segment into two congruent parts. Okay, that's the definition of a midpoint. A midpoint, let's write it somewhere over here. Oh, right here. Definition of midpoint. It's a point that splits a segment. Wow, I can't spell. A segment into two congruent parts. So the definition of a midpoint is always going to prove that two things are congruent to each other. Now let's go to what this is saying. It says, Jess wanted to prove that the triangles are congruent. Good for you, Jess. He was only told that E is the midpoint of AC and it's the midpoint of BD. Okay, so E is the midpoint of AC. So if this is the midpoint, it splits it into two congruent parts, which means this one is congruent to that one. So we know those two are congruent to each other. And here we see E is the midpoint of AC. What can we tell from that? We can tell that AE is congruent to EC. Why? Because that's the definition of what a midpoint is. Midpoint splits a segment into two congruent parts. All right, it also says that E is the midpoint of BD. All right, so here's E, here's BD. E is the midpoint again. That means this one is congruent to that one. So since E is the midpoint of BD, I can say that BE, segment BE, is congruent to segment ED. And the reason why I can say that is this reason over here, definition of a midpoint. All right, so what do we have so far? I've got a side, I've got a side. I'm trying to prove the two triangles are congruent because that's what Jess wanted to do. I need three things, and that's why you have another blank. But they didn't tell me anything else. But there's still things that we can discover here. Remember, if these two angles are vertical angles are congruent. So I can say, since those two angles are vertical angles, they're going to be congruent to each other. So I'm going to say that angle AEB, so angle AEB, is congruent to angle DEC. And why do I know that? Those are vertical angles, and vertical angles are congruent. All right, so what do we have here for these two triangles? Well, I've got a side, angle, side, side, angle, side. So it looks like I'm using side, angle, side congruence. So I'm going to say these two triangles are going to be congruent by side, angle, side congruence. So I can say that triangle, we'll start here, ABE. So triangle ABE is congruent to triangle. Now, what the order matters. So since I used A, and A is between this blue tick mark and the blank, I have to start with C over here because it's between blue tick mark and blank. So I'm going to say C, and then D, and then E, because we have to put them in the correct order. All right, what series of rigid transformations, so this is like that last lesson, would map one of these triangles on top of the other one? Well, we can see here that if we rotate the triangle around with the center of our rotation at E, that we could get D over to B and C over to A, and then it'd be on top of it. So there's only one transformation we need here. If I rotate triangle EDC about point E, that would put one triangle on top of the other triangle. All right, good, good, good. All right, next part. For each of the problems below, determine if the triangles are congruent. If they are congruent, label the vertices and create flowcharts for them on a separate piece of paper. All right, so we're going to have to do a flowchart on these if they're congruent. If they're not congruent, we're in luck. We don't have to do anything. So on this one, I've got one segment and one segment, but I need three things proven congruent. So I have to ask myself, can I prove anything else is congruent here? And the answer is yes. I have the reflexive property. I now have two things congruent. Is there anything else I can prove congruent? The answer is yes, because they told me these lines are parallel. Remember, when we have parallel lines, that usually indicates that angles are congruent. Alternate interior angles, corresponding angles, or alternate exterior angles. And so we have here, with this line and this line being parallel, and this being our transversal, we can prove using alternate interior angles that those two angles have to be congruent. And now I do have the three things I need. I have side, angle, side, side, angle, side. Okay, so we're going to have to do a flowchart for this because we were lucky enough to prove that they are congruent. So I'm going to call this one A, B, C, and D. All right, flowchart time. Here we go. Okay, I'm going to start with what they gave me. They gave me the DC and AB are congruent. So DC is congruent to AB. How do I know? It was given. They told me. Tick mark right there. Boom. Next, let's do the angles. This angle here and this angle here. So I'm going to say angle DCA is congruent to angle BAC. Why? Because they're alternate interior angles, and alternate interior angles are congruent. So write that out. Alternate interior angles are congruent. Boom. I've got a side. I've got an angle. Let's do this last side. We can now say that AC is congruent to AC from the other triangle. AC is congruent to itself. That's the reflexive property. What do I got? I got a side congruent. I got an angle congruent. I got a side congruent. Put those three statements together, And we have now proven those two triangles have to be congruent. So I'm going to say that DCA is congruent to triangle. Let's see, I started with D, so I'm going to have to start with B over here. And then I went DC, so I'm going to have to go BAC. So triangle BAC. And my reason is side, angle, side. All right, first one down. Let's look at our next one. On our next triangle, we've got an angle and an angle. We've got a side and we've got a side. Two things. I need three things. Aha, I do have a third thing right there. Is this one of our congruence theorems? Let's see what we got. We got angle, side, side. Ooh, don't write that down. Or we've got side, side, angle. And plus, these are in the wrong order. Look, this angle's touching the 1 tick mark side on this triangle, and this angle's touching the 2 tick mark side on that triangle. These are really messed up for a couple reasons. Number one, this is side, side, angle, and if you spell it backwards, it makes a donkey. Donkeys don't make triangles. That's not going to work, my friends. Leave it out. So no, these are not congruent. We can't prove it. Cannot prove. There's just not enough information there. I mean, it's possible they're congruent in some way, but they didn't give us enough information to prove it. Part C. This angle and this angle are the same, because they told me. This angle and this angle are the same by the definition of congruence, because they're the same measurement, so they must be congruent to each other. And on top of that, I could prove that this angle here and this angle here are the same because they're vertical angles. Three things. Is it congruent? No, that's angle, angle, angle. It's like going to the dentist. Dentists don't prove congruent triangles. All right, so that doesn't work. Angle, angle, angle is not one of our congruence theorems. I need a side, and they didn't give me any of them. So not enough info. Part D. I've got one side and one side. That was nice. I've got two side, two side. I've got two things proven congruent. Do we have a third? Yes, we do right here. Reflexive property. So we can prove this one using side, side, side. So let's label it A, B, C, D. Let's do a proof or a flowchart to prove that those two triangles are congruent. All right, so we're on part D here. Okay, so I'm going to do side, side, side. Let's start with this side. AB is congruent to AD. Given, they told me. Next side, the 2 tick mark side. DC is congruent to BC. Given, they told me. Now, they didn't tell me this next one. So AC from the top triangle is congruent to AC from the bottom triangle. Reason? That's the reflexive property. Anything can be congruent to itself in the reflexive property. We've got a side congruent, a side congruent, a third side congruent. That is one of our congruent theorems. So we can say that the triangles are congruent. So I'm going to start with ABC. So triangle ABC is congruent to triangle. Now A up here is between 1 and 3. So let's go down here. A down here is also between 1 and 3. So on the bottom triangle, A and A correspond to each other. Our next letter was B. B is between 1 tick mark and 2 tick mark, and D is between 1 and 2. So B and D correspond to each other. On the top triangle, C is between 2 and 3. On the bottom triangle, C is between 2 and 3. So C and C correspond to each other. So there's my two congruent triangles. And we know because of side, side, side congruence. All right, we are flying. Last one. I've got one thing. I need 3. Can we add anything? Boom. I can add that because those are reflexive property. So BD from this triangle is congruent to BD from that triangle by the reflexive property. Parallel sides again. We've got parallel sides, and then this is a transversal. Hopefully you see that this angle here and this angle here are alternate interior angles. So those can be proven congruent. So do we have congruent triangles? We have 3 things, but is this one of our congruence theorems? See, I've got angle, angle, side, angle, angle, side, and it's in the correct order. So yes, this is angle, angle, side. Forgot to write down these ones. This one was side, 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 and this one was side, angle, side. All right, so that means, yep, we have to do one more. All right, so let's do our last one here. Oh, this one already had letters on it. That was nice of them. Why did some of them have letters and some of them not? I don't know. Let's not ask these questions. Okay, so let's start with the 1 tick mark angles. So we can say that angle A is congruent to angle C. Why? They told me. They put tick marks on it, for goodness sake. So they must be congruent. Okay, we're using angle, angle side. So let's do the angles next. So the 2 tick mark angles. So this angle I'm going to have to call BDC. I can't use just one letter because there's multiple angles at D. So BDC, BD, there you go, C. So BDC, so that's this angle, is going to be congruent to ABD, that angle. So angle ABD. Why? We said they are alternate interior angles. We have parallel lines, transversal, they're on different sides of the transversal, and they're both on the inside of the parallel lines. So that's called alternate interior angles. And we know that alternate interior angles are congruent to each other. That's why we can write that statement. That's our reasoning. Almost there. We have an angle, we have an angle, we need the side now. So we're going to say that BD is congruent to BD. Angle, angle, side, reason, reflexive property. So these 3 statements together lead to one conclusion. ABD must be congruent to CDB. Because of angle, angle, side congruence. Done. Record time. Like a boss. All right, that's all I got. I'm going to go home. It's time to eat. See you later. Bye-bye.